Good morning! To make our Sprite class, we'll start with creating a draw view, just a remake of what we did last time. Remember, it extends view, and when we do that, it's going to be unhappy and says, hey, Alt Enter, and it says, got to import view, but it's still unhappy because it says, hey, I need a constructor. And then which one do you pick? So we're going to use the one that receives a context and an attribute set. Now it's happy. But we want to take over this draw view. So remember on draw. Wow, the computer will catch up to me. Okay, so we have the basics. There's our draw view, custom view. Let's go ahead and put it into our layout. We're gonna let's take away this part. Let's make it a view, just a default view. And we'll put in a class here. Let's see, what is our, this is our path right now. Oh, look at that, it brought it up for me. So I'll hit enter, and there's our class. We're gonna see what the default constraints are. Bottom of the parent, left of the parent, right of the parent. Okay, we don't need so much, but we'll leave it like that for now. Wrap content, put around the content. Let's just do match parent. All right, so we should have our default. Draw view, pointed it. Now we can make our sprite and then load our sprite. The reason we want to use a sprite class is that by encapsulating our animation inside of a single object, the object will know its own position, its own size, its own color, its own characteristics, basically. And if you have 50 different sprites on, it's a lot easier having each sprite handle itself and keep its data collected within itself, rather than you, the user or the programmer, have to figure it out and try to keep track of it. If you want sprite 1 to move to the left and sprite 2 to move to the right, you don't have to go and say, hey, move your left corner left over 1, your right corner left 1, and then for the second sprite, do the opposite. You could just tell each of them to update, and they'll move in there correspondingly. Positions makes life a lot easier. We could start Sprite from scratch, but there is a nice class called rectf. At this time, you really should go look up the rectf class. I don't know what it wants. There it goes. So we're going to import that, and you should read the API. Now, if you're really lazy, you can hit Control B right here, and Control B takes you to the declarations page for the rectf class. And so here you should note that they do have 4 public data fields: left, top, right, bottom. It has a constructor, and please pay attention to the order. It's left top, so the top left corner, and then the right bottom, that's the bottom right corner. So it's different from other classes and methods you might have seen that are rectangular in shape. Sometimes they'll do width and height here, but we're not doing width and height here. You're doing the right corner instead. So keep in mind, right always has to be bigger than left, and bottom has to be bigger than top. Remember, in Android programming and graphics, your bottom is going to be a higher coordinate value than a top, which is going to be a lower coordinate value because that's 0. All right, and then what's more valuable is some of these other methods that come with it. In particular, we'll be using, well, width and height are important. Center X, center Y, so it can calculate its middle for you. Setting, that's useful at some point. Offset, we're going to play with. And that will, remember how we just said we can move it left and right? That's what the offset will do. Move left a certain amount, right down a certain amount. And it moves all the data fields for you. And an offset too is like a teleport command. And it'll teleport to this new XY coordinate, moving the top left corner there, and then moves the bottom right accordingly. This contains, where you click a point, and you can say, hey, sprite A, do you contain this point that I just clicked? and so forth. There's also intersects, which is super valuable to us. It's determine whether two rectefs collide with each other. Let's go back to our sprite class and actually do these things. I'm going to do Alt, Insert, make a constructor with everything. So we'll start with everything in there. So left, top, right, bottom. But since this is going to be our everything constructor, let's go ahead and put in an int for dx, an int for dy, and what else should we make? Oh, color, an int for color. And then you can go int dx, dy, color. And remember, these should be private. You can make them public, but we should keep them private so other classes and stuff can't mess with it. Let me go ahead and stretch this out so you can see the whole thing. So that's what we could do, and then we need to put this in. So this dot dx equals dx, this dot dy equals dy, this dot color equals color. Now, oh, I messed that up. That should be a lowercase c. There we go. For those who don't remember, the this means the current instance of Sprite, and so it takes the dx from right here. So notice in Android Studio, when I double click a variable, it tells me where it's pointing at in all its references. dx is right here, and it gets stored into this dx. See, notice how this is now highlighted up here? So that means the current instance dx. Do that. That was all wonderful. But let's say we didn't want to do that. Actually, you know what? Let's get rid of it all. Let's say we put the data fields in first. Then you hit Alt Enter, constructor, and then you can put in. And then it says, hey, do you want to do these other private data fields you have? I'm like, yeah. So I do Shift and then arrow down to select them all, hit OK. And now look at that. It made me a constructor with everything and instantiated all the variables for me. Again, if you put the data fields first and then do Alt Insert, you can create a constructor that does that for you. Our next constructor will be, what if we wanted a default a custom size, but default speed and color? We'll go like this. We'll probably want to do a constructor where we said custom size. So this will need this. And we say, hey, we're going to use default for that. So we're going to select none. There we go. Okay. But we already have a constructor that sets these values. We're going to use this, and we wanted to call this constructor. But in order to call the constructor, we need three more things. We'll say, hey, pass in these four custom dimensions, and then just use a default color, speed and color. dx will be 1, dy will be 2, and then we can do any color we want. We're going to use magenta it is. That's our default color if we only do size. Let's do that again, and this time we'll reverse it. What if we want to do just a custom color, speed, and then default size? So that means we're not passing anything in. So just use this one. And we're going to take in these three. So now it says pass me these three. Okay. And yes, we could do this, but instead, oh, whoops. So we want to pass these three up into this constructor. So that means it needs four things. So it needs a default. Now let's do a default right corner. Okay, so that's the left, top, right. So you notice this is bigger than the left, and bottom is bigger. Now we can pass in the dx, dy color. And that will pass it to this constructor. Okay. Notice how I'm just building on using the same constructor. Let's do a default because we're going to want that probably at some point. Let's do Alt Enter, constructor, enter, nothing. Select none, please. Thank you. There's my default constructor. That means I need to do some default. And I could go all the way back here and set the default values, but I'm going to just use this constructor. I'll pass 3 things in as my default colors and so forth. What shall they be? Let's do 2, 3, color dot green. There really is a green right there. There we go. Now we have our constructor. We made it. We could test this at this point, but I'm not going to. I'm going to go ahead and do the update and the draw method first. So these are methods, you don't have to have them, but you generally want them in game design. Update will be usually the method that covers all your movements, your color, your detections, your change of direction, change in color, change of image, whatever your status is. Change the number of lives you have, the hit points you have, whatnot. So there we go. We're going to do an update. And in this case, we're just going to move offset by its speed. That's all it's going to do. Just move for our sake. No detection or anything. And then we want our sprites to be able to draw themselves. But the problem is when you draw yourself, you need a canvas to do that. So it's going to have to put in a parameter for canvas. And then Alt Enter to import the canvas. See it imported canvas for us. Let's make a paint. And Alt Enter to put that in. Let's set the color. My own color, it's whatever I am. Each sprite has its own color. This is going back to that, hey, you keep track of your own color. That way it makes programming and our lives a lot easier when we can encapsulate data like that. And to draw it, we're going to just draw a circle right here, right where I am. Now I need a center X, so I can just say, hey, I'm a recdef. I know where my center is, so I can use the center X method. That'll return the center. A center Y. I need a radius. I'm going to use my width divided by 2, right? And I need a paint. So that'll be the color I'm going to draw myself. All right, that's a good stopping place to test our drawing. So we're going to come over here and say we should never instantiate an object inside of on draw. We'll probably declare it here. Sprite, horrible name. You'll have a better name for yours that's descriptive of what you're doing. And we're going to use the default constructor. All right, so now it's instantiated. Like I said, this works and this is okay. Just to demonstrate, I'm going to do on layout change. So the problem is right here, you can, if you have raw numbers, concrete numbers, you can put them in here. But if you want to use it with respect to get width and get height, at this point, get width and get height is 0. So you may not want to do that. So you could do something like this, copy, paste it here, and instantiate inside of on layout. So at this point, it records the screen size, and therefore it is able to do get width and get height, or the view size. So here you can do some percentage of get width, get height if you wanted. Okay, so optional, didn't have to. Now we probably want our sprite to .update itself. So in our case, update means move, and sprite .draw yourself. But it needs a canvas to do that. We'll put that in, and we want move, not inflate, invalidate. There we go. That will say, hey, update yourself, move. And you can start seeing the problem here. This is going to be a really fast movement because the moment this is done, it will invalidate and try again. Let's go ahead and run it and see if I've broken anything. There we go. Oh, you may not be able to see it. I hope you can, but there's a little green dot flying across the screen. Let's go back to our sprite, and there's our default, and it can't control the size. Oh, wait, here we go. If we're going to pass these three up here, we can change the size here. Let's make this 110, make it a square. Run it again, installs the app. There he is, just a little easier to see. Then the other things we want to do is probably, we have our private data fields, so probably want to give access, public access to that. Do Alt Insert again, put in all the getters and setters. I'm going to go highlight them all, so give them all to them. Now, you may want to put conditions on when they can do one of these, or they can say they have to be positive numbers, or put constraints in as you see fit for your program. But I just put defaults, and there we go. Sprite class.